In this lesson, we're going to talk about square roots of perfect squares. Before we begin, take a look at all of the numbers on this slide. Are they all perfect squares? If so, why? See if you can come up with your own definition. A number is a perfect square if it can be written as a product of two equal whole number factors. A fraction is a perfect square if it can be written as a product of two equal fractions. So for example, 4 is a perfect square because it can be written as a product of 2 times 2. Four over 9 is a perfect square because it can be written as a product of 2/3 times 2/3. In other words, a fraction is a perfect square if its numerator and denominator are perfect squares. Let's look at some more examples. Let's look at the fraction 72 over 98. Is this fraction a perfect square? In order to determine that, what we need to do is first of all write the fraction in lowest terms. In order to do that, we take the top and bottom and divide it by their greatest common factor, which in this case is 2. So we now have a new fraction, 36 over 49. So if we look at this fraction, 36 over 49, can be written as a product of 6 over 7 times 6 over 7. In other words, 36 and 49 both have numerators and denominators that are perfect squares. So 36 over 49 is a perfect square. Calculate the number whose square root is 1.5. In this problem, what we need to do is to visualize a square. And I'm going to draw a square as best as I can. But what this really means here is that we have a square with a side length of 1.5 units. As you remember from earlier classes, if we know the side length of a square, we can calculate its area. And that's what this question is asking you to do. So it's asking you to find the area of a square with a side length equal to 1.5. So the number whose square root is 1.5 is just equal to the square of 1.5, which is 1.5 times 1.5, which is equal to 2.25. The same logic we used when working with a decimal number on the previous problem can be used to solve a problem like this one. Calculate the number whose square root is 2 over 5. So in this case, all we need to do is to find out what the square of 2/5 is. So 2/5 squared is just equal to 2/5 times 2/5, which is equal to 4 over 29. Or 4 over 25, sorry. So again, when solving problems like this one and the one previous, if you're calculating a number where you know the square root, all you do is square the number, multiply the numerators together and the denominators together if we're working with a fraction. For the last example, let's look at how to identify if a decimal number is a perfect square. So let's look at the number 6.25. So how can we determine if that number is a perfect square? One method is to write it as a fraction. So 6.25 is equal to 625 100ths. And from that point, what I can do is simplify the fraction. So in this case, I can divide the top and bottom by 25, which gives me 25 over 4. This can be written as a product of 5 over 2 times 5 over 2. Since this can be written as a product of two equal fractions, we know that 6.25 is a perfect square. Another way to do that, let's finish my thought here. Another way to do this is also to use a calculator. So if I allow calculators, what we can do is hit the square root button. If a fraction ends, or if a number is a terminating decimal, then we can say it is a perfect square. Okay, let's look at one last example. In this example, the square has an area of 3.084 square centimeters. What is the side length of the square? So from a previous problem, we learned that if you square the side length, you can find the area. So conversely, a side of any square will just be the square root of its area. So in this case, I know the side length is equal to the square root of the area, which is just the square root of 3.84 centimeters squared, which is 1.8 centimeters. With any word problem, it's always important to make sure you keep the units in the problem. So we can use this to find part B. So part B says, what is the area, or the perimeter of the square? So the perimeter of any square is just equal to 4 times the side length, which is equal to 4 times 1.8 centimeters, which is equal to 7.2 centimeters.